we can theoretically know what happened a tiny fraction of a second after the Big Bang. To be precise, I am talking about 10 to the power of negative 43 seconds after the Big Bang. But what about before that? Well, we do not know for sure, and this is where it gets interesting. This unknown period just after the Big Bang is called the Planck Era. We believe that during this time, the four forces that we know today, gravity, the strong force, the electromagnetic force, and the weak force, were combined into a single, unified force. The Planck Era is a time when the universe had no volume and an infinite density. This state is known as a singularity, which means that our usual laws of physics can't apply. The Planck Era is where quantum mechanics, which describes the behavior of particles, and general relativity, which explains the force of gravity and the structure of space and time, both fail to explain what happened. These two theories have fundamental unit length, the Compton wavelength and the Schwarzschild radius. They define the smallest scales we can currently observe a particle. In simple terms, the Compton wavelength is the wavelength of a particle at rest and sets the limit on how small we can measure an object. And the Schwarzschild radius is a limit on how small and dense something can get before it collapses under its own gravity. When we reach these two limits for the smallest object possible, it would take a photon, the fastest thing in the universe, only about 10 to the power of negative 43 seconds to travel this tiny distance. So from the Big Bang to the end of the Planck Era, we are not sure of what happened because we cannot calculate it. At these incredibly small scales and short times, our current theories of quantum mechanics and general relativity can't fully describe what happened. However, what happened during the Planck Era laid the foundation for everything that followed in the evolution of our universe.